Hi everyone, and welcome to GISC 125, Mapping and Spatial Thinking. So today I'll discuss what spatial thinking is and how we can use it to solve geospatial problems. So I want you to think, what do you think spatial thinking is? So spatial thinking is an ability to visualize and interpret location, distance, direction, relationships, movement, and change in space. So spatial thinking involves knowing about space and using different representations of space and making reasonable decisions concerning space. So thinking in spatial terms is essential to knowing and applying geography. So it enables people to take an active, questioning approach to the world around them and to ask what, where, when, and why questions about people, places, and the environment, for example. So spatial thinking enables people to formulate critical questions about past, present, and future patterns of spatial organization, to anticipate the results of events in different locations, and to predict what might happen given specific conditions. So my interest and the focus of this class lies mostly on geographic side, or perhaps a better definition is labeled as geospatial thinking. Because spatial thinking could be just simply like if you have a child and you're building blocks, or you're fitting in geometric shapes into certain holes. That's spatial thinking. In this case, we're going to talk about geospatial thinking. And this overlaps some with geoliteracy, which has also been receiving increasing attention. So my working definition of geospatial thinking is identifying, analyzing, and understanding the location, scale, patterns, and trends of the geographic and temporal means time, relationships among data, phenomena, and issues. So throughout the semester, we'll be returning to this definition through examples to better understand these things. And so I think kind of using some examples of what spatial thinking is will help kind of solidify what this definition means. So here we're going to look at the 2012 presidential election results. And some of you might have seen a map like this, maybe you haven't. And so I'll kind of go over what this map is all about. And so first off, this is a choropleth map of the contiguous United States by county. And so it's the presidential election results are presented as a percentage of the county vote for voters voting for either Obama and the percent voting for Romney. So counties with greater than 50% results for Obama are in blue, and oppositely, those greater than 50% for Romney are shown in red. So deeper blue and deeper red colors indicate higher percentage of votes for that candidate. So for example, voters in Washington, D.C. are highly favored for Obama, and voters in Idaho generally favor Romney. We can see that Idaho is more red, Washington, D.C. is far more blue. So are there any patterns in this data? Can you see anything quickly? Does anything jump out at you? And what do they reveal? So some examples that we might say about the major urban areas. So for example, Seattle, Tacoma is really blue. San Francisco metro area is really blue. Los Angeles metro is very blue. Same for Chicago, Detroit, Boston, New York, Philadelphia, Washington, Miami, San Antonio, Austin, Houston, and Texas. All these are all very blue. So we can look at these urban areas and we can see that they're very, very blue. Lots of Texas college towns as well. We can see that they're blue. Same with the coasts are blue. Also, high density urban areas, as I just pointed out, on the East Coast and West Coast are generally blue, which vote for Obama or Democrats. For the moment, let's define minorities as kind of Hispanics, blacks, and Native Americans. Can you tell from this map below how this majority votes? Some clues: Imperial Valley in southern Nevada, Miami metro area, southwestern border of Texas, Mississippi, the Southern Belt, and Native American reservations across the northeastern Arizona, northern New Mexico, Dakotas are all blue and all Democrats. The Midwest, which the media often refers to as the flyover country, and rural areas generally vote red, Republican. So with so much red on the map, how did Obama win the election? Well, let's take a look at this. So this map shows the population density by county. And notice that areas that are largely red have a very low population density. So we can look on this flyover Midwest population density under 11 people per square mile. While areas that are high have a large blue have a high population density. So since electoral college votes are based on the population of a state, so places like in Los Angeles that has a high population density, it's in California, New York, for example, Florida, have a lot of electoral votes. Places that don't have a very high population density, like Idaho, don't have very many electoral votes. So you look at the map, Ada County, Canyon County seem to have kind of the highest population densities. Same with up here, which is a college town. I don't remember the name of this county. So do you think there's any correlation between race, ethnicity, and voting pattern? So here we can kind of quickly look. The very deep blue is a great percentage of whites. Here, greens represent African Americans. We have here Hispanics. So the darker the color, the higher percentage of Hispanics. In Miami as well. Yellow represents Native Americans. A lot of these red, yellow dots, these are Indian reservations. So is there any kind of voting pattern here? Well, if we look at these two maps side by side, there certainly is. Look at here where the African Americans are, along the Mississippi, southern areas. Hispanics, we can see definitely along the coast here, or not the coast, but along Mexico, Texas border. We can also see lots of white people along the coasts vote Democrat. A lot of blue areas, a little bit more red. So there seems to be some kind of correlation of race, ethnicity, and voting. So population below poverty level, we can look here at poverty. We can see again the South, Hispanics, Native American, Indian reservations, and so forth. Is there any kind of correlation to that? Perhaps. It looks like that on the map. Here we have median household income by county. So deep red has a higher median household income. Kind of the more lighter yellow has a lower median household income. Is there any kind of correlation with that? There seems to be, but you can also notice along the coasts of California, very high median household income, very high median household income. Same, looks like predominantly blue, especially up here in Seattle. Very high median household income, but they also seem to vote Democrat. Same with the East Coast. But we can also see some patterns here in the South and so forth. So there seems to be maybe a little bit of a correlation there. So here in this map, the purple map, as these are referred to, but this is for the 2016 presidential election. And so this map is generally the same pattern as we saw in the 2012 map, but the only difference is that we see an area in Utah, right? And we see this yellow area, which represents Gary Johnson, who was from Utah. I think he was from Salt Lake City, but I don't recall. But you can kind of see he did seem to gather some kind of votes there as well. Also kind of interesting, the purple map here, we can see very blue. This is Blaine County, 5B. This is where Sun Valley is. So very high median household income in there. We also see Ada County has probably a higher median household income than other counties besides Blaine County. So again, we can see the South, very blue in these areas, and the coasts as well. So by spatial thinking, we've identified data patterns, right? In terms of urban areas, rural areas, the coast, in terms of where people voted. You have identified several links between voting patterns and socioeconomic and demographic factors. And we've all this visually, and we did this in a few seconds. It didn't take long, so we can see some, by mapping this, we can see where people voted, we can see patterns, we can then kind of look at socioeconomic and demographic factors and see how they are correlated. So the most important questions about spatial thinkers they ask is not where, but why. So where by itself is important, but it stops there, cuts short kind of spatial thinking and the subsequent spatial analysis that could result. At its best, where by itself is a scaffold upon which we can hang other geographic knowledge and build skills. At its worst, where by itself is just a place name, imports and exports, and capes and bays, memorizing stereotypes that make geography and educators kind of twitchy. To nurture spatial thinking, we must couple them with the why. So in essence, spatial thinking includes processes that support exploration and understanding of the data. We don't want to just know where something is. That's boring for the most part. We understand why. So spatial literacy is the component and the confident use of maps, mapping, and spatial thinking to address ideas, situations, and problems with daily life, society, and the world around us. And so this course is going to aim to help guide you to become more spatially literate. So here is a great map. This is a map by Dr. John Snow, who is also referred to as the father of epidemiology and spatial analysis. And he really developed some critical spatial thinking concepts, including point clustering and really the kind of zone of influence. So this is a map from 1854 near London, where there was an outbreak of cholera. And cholera is a waterborne disease. They didn't know it was a waterborne disease at this time until John Snow, but it causes diarrhea, dehydration, and then you pretty much die. And he was kind of mapping and treating these people and really mapping the locations of these deaths. And by making this map, these locations are these little black lines, and each line represents a death. And you can see there's many, many deaths. And his goal was to find out what is causing these deaths. And there's many different theories. There was this theory of smells in the air, and these smells were causing people to die. But John Snow thought it was something with the water, and this was before they understood bacteria in the water. They didn't have microscopes and so forth at that time. And so essentially he mapped these deaths, and he kind of identified this pattern, these clusters, kind of around the Broad Street pump. There's many more deaths here. And there's actually a pump here called the Broad Street pump. There's other pumps around here that are hard to identify, but they're kind of around the city. But most of the deaths occurred around this Broad Street pump. And John Snow convinced the city officials to remove the pump handle from this Broad Street pump. And they reluctantly did it, and lo and behold, in no time, cholera deaths started to dwindle. And so it was kind of realized that, hey, this is actually a waterborne disease, and it's coming from the Broad Street pump. And so this is kind of a great example of spatial thinking. As I said, John Snow was kind of one of the first people to really understand this kind of spatial analysis. Here is another thinking of spatial analysis. Here we are in New Mexico. And what do we notice about this pattern here? Well, there's clusters of trees identified in these green areas, and most of New Mexico is kind of bare. So why are there trees in some areas and some trees in no areas? That's a spatial thinking kind of question. And so elevation plays a role, and the angle at which the mountain is facing, whether it's a north facing or south facing slope, is going to influence how much rain, how much sun, etc. is going to be there. So these trees are not just randomly placed, but they have correlations with the geography of the landscape, the physical geography. So thinking spatially, because if we look at a river system here in Texas, and we think about what's going on here in this river system, we can get a general pattern or trend where all the rivers flow in a certain direction, and without knowing anything else, I kind of hope you understand your geography well enough to know why the streams would flow in a certain direction. And so we can start to see that we have elevation change from the west to the east towards the Gulf of Mexico. So as you can see, those rivers patterns all generally trend down towards the Gulf and ultimately into the Gulf of Mexico. And so as you can see in the west, higher elevation and then lower elevation towards the east. So that's exactly why these rivers are flowing in this direction. Again, you're just kind of thinking spatially. Why are these rivers flowing in a particular direction? Elevation. So finally, kind of this effective spatial thinkers need kind of three general things, areas. So the skills are important, or many, such as adding and manipulating spatial data, changing legends, working with pop-up information on your maps, working with tabular information, working with scale, and other things such as spatial statistics, map projections, querying and sorting data, overlay operations, map algebra, and so forth. So there's lots of different things that we're going to be needing in our skills and our tool set to do. Increasingly, the skills required includes geospatial technologies such as GIS, GPS, and remote sensing, as well as mathematics, computer science, and also personal that have competencies such as being organized and ethical. So lots of skills are required to be a spatial thinker. Content knowledge is critical to success as well. For example, to work with climate data in a spatial context effectively means that the student understands how climatic systems work, including the intertropical convergence zones and local convections, the effects of mountain ranges and ocean currents, air pressure, water vapor, and much more. So to work with this climate data, you have to know about these things. And the same is true for other concepts such as watersheds, ecosystems, energy production and consumption, the dynamics of population change, natural hazards, and how they impact human environments. So you have to have some kind of content knowledge as well. And finally, the geographic perspective is critical. So the geographic perspective begins with asking relevant, thoughtful questions. So the geographic perspective is seeing the world as a system of interconnected systems from local to global, and each united by some location or set of locations in a spatial pattern, or sometimes having no discernible pattern, but still based on some kind of location. So the geographic perspective is tied to geographic inquiry, and the geographic inquiry process entails asking a geographic question, gathering relevant geographic data, analyzing that data, assessing that data, making a decision based on that data. And this process often leads to additional questions, which in turn leads to additional gathering, analyzing, assessing, and decision making. So it's a problem-based approach and is similar to the scientific method. And we're going to go into detail later on in this semester here about geographic inquiry. So spatial thinkers need to have a skill set within these three spheres here.